Okay, this is example number 3 for Vertex form. We're going to go ahead and graph this thing. You'll notice it's in standard form right now, so we're going to follow the same steps we've been working on. I'm going to go ahead and get rid of this f of x, and over here to the right, I'm going to put equals 0. I now want to get this positive 2 to the other side, so I'm going to subtract 2 from both sides. So if I rewrote this, I would have 3x squared minus 6x equals negative 2. All right, I'm going to end up turning this left side back into another trinomial, something that factors nicely the way I like, but I really don't like factoring if I have a leading coefficient here. I'd prefer that number to be 1. But I do notice that 3 goes into both 3 and negative 6, so I can pull that number out of both those terms. So on the outside here, I'll go 3, and now I have x squared, and I have negative 2x. And you'll notice I left a gap here because I'm going to plug something in here that turns it into a trinomial that factors the way I want it to, and factors into what we call a perfect square. Now, what goes in this spot, okay, will always be the same formula, and it's b divided by 2. And you'll remember, going back to your quadratic formula days, this is a, this is b, this is c. Now, I don't want to use the b up here in my original. I want to use the b here in the one that I simplified and took the 3 out. So what I would get here on the left for b is negative 2 divided by 2. And what goes in this spot is negative 1. Okay, so I'm going to go ahead and clean this up a little bit. 3 times x squared minus 2x. And we know negative 1 squared is positive 1 equals negative 2. Now, I don't get to just magically add a plus 1 over here without doing the same on the right side of the equation here and balancing it out. Now, remember, I'm not just going to add 1 because I do have this 3 here. And if I were to go back and get rid of those parentheses, it's really, I'm adding 3 times 1, which is just 3. So let's clean it up even more. I'm going to scroll up a little bit. I've got 3, and I'm going to go ahead and factor this left side. X times x gives me x squared. My signs have to be the same, and they both have to be negative. And the only numbers that multiply to 1, okay, and add to 2 would be 1 and 1. And if you have trouble factoring, you can also then look up here, and whatever goes in these terms, it will always be this b divided by 2. And then on the right side of the equation here, we just have negative 2 plus 3, so that's a positive 1. And last but not least, I'm going to go ahead and clean it up a little bit more. And move this out of the way. I'm going to put it back in function notation. F of x equals 3 times the quantity, or excuse me, x minus 1 quantity squared. And then I would move this back over by subtracting 1 from both sides, minus 1. And this is my factored form of this quadratic. Okay. Below it, I'm going to go ahead and put the formula for the factored form here. And I'm looking for h and k. And let's do k first. K is always the easiest. That's going to take my parabola and shift it up and down. So whatever's on the outside here, this is my k. And if I were to write the vertex here as a coordinate point, okay, my k is minus 1. So if that parabola, we know it opens up because it's a positive 3, is going to shift down 1. And then for my h, you'll notice subtraction is part of the formula. And right here, the only way I could have a negative 1 here is if I plugged in a positive 1. And again, it's a little bit backwards from what you think. This is going to be my horizontal shift. And it says x minus 1, usually negative 1 you would think to the left, but really it's to the right. And that also gives me my line of symmetry, or my axis, we call it. So I can go ahead and plot these points over here on my graph. My vertex is going to be to the right one, down one. My line of symmetry is going to look like this, cut right through the middle. I know my parabola is going to go open upward because of that 3, and it will be stretched vertically because of that 3. So just general rule of thumb, I know it's going to look something like this. But I'm going to go ahead and type it in the calculator to get some cleaner points. So we'll turn that on. You notice I already programmed it in. We'll look at a graph. It's going to look somewhat like this. We'll look at a table here. And I notice at 1, -1, that's the lowest point for my y values, so my vertex looks good. And then I'll also use this point to go ahead and plot some nice clean points. And really, those are the only clean points that fit on this particular graph, so that's all I'm going to plot. And then I'll connect them with a nice smooth, and my graph's complete.